Okay, if you are new to this channel, please, and I'll hold you to please subscribe, like, and share. Today, I want to talk about the set operations. If you check the former videos, you'll see the Venn diagrams, but today is set operations. And I need to correct one motif that is the operation under set is actually different from types of sets. Under the types of set, that's why we have the singleton set, the set that has just one member. We have the empty set that has non-member, it does not have any member, that's empty set. We have the indefinite set, we have infinite set, we have finite and infinite. You know, when we say infinite, it has no end like natural numbers. And we have the infinite set, that one that it has an end. It has an end, like the month of the years. That is finite set. But when I say the numbers, natural number, that is infinite, because natural number has no end. And also, I have to make it clear, when we said natural numbers start from the 1 and continue, but natural number does not, 0 is not the natural numbers. And integers, what do we call integers? Integers can be positive numbers and the negative numbers. But don't forget that natural numbers has no 0. 0 is not among the natural numbers. Natural numbers start from 1, 2, 3, 4, 5, 6, and so on and so forth. So that's that. And another thing is that the prime numbers start from 2. Is not 1. Prime numbers start from 2 is not 1. So that is that about that. And another thing is composite number. What do I mean by composite numbers? Composite numbers are numbers that are not prime. Composite numbers are numbers that are not prime. Okay, let's go to the set operations. Now the set operations, we have the additions, we have the subtractions, we have the complement, we have the union, we have the intersection, we have the universal. This universal can be regarded as a mother of all sets, because so far you are talking about universal, so you talk about, because under universal you see intersections, complement, union, and all these rest. That's why you can refer this universal as a mother of all sets. It's a mother of all sets. Now, okay, let's take some questions and we solve it together. Now let's look at this question 1 on the board. When you see a symbol like this symbol, it represents universal. Either they use this symbol, or they can use this, or they can use U. All of these things represent universal. And I told you universal is the mother of all sets, because inside universal you see many other sets. Look at this one now. It's a universal set. If you look at M, everything you find in M can also be found in this universal. Everything you find in this N can also be found in universal. So that's why they refer it as a mother of all sets. So that's why anytime you see universal, you see many sets that will follow. Okay? Now, so look at this. You say find M prime. This name is prime. Union N prime. The union, like the one out of the set operation, you see the union. The symbol for union is this. While intersection is this. This is union, this is intersections. But when you hear complement, like the word complement, so like if I write M like the word right now, this complement, or prime. This is prime, but you can also do like this. But they mean the same thing. Of prime and complement, they mean the same thing. Let's see what they are talking about. They say find M prime union N prime. Now let's do the M prime first. M prime. What does that mean? Please, when you are using bracket for set, you use this kind of bracket. Don't use algebra bracket. That is wrong. Now, M prime, what does that mean? Let me say the meaning of M prime. M prime means that it cannot be found in M but inside the universal. That's the meaning of M prime. This means that M prime means cannot be found in M but in universal. How do you mean? Means can't be found in M but in universal. Now, if it cannot be found in M, let's look at M. All these are called elements. They are called elements or members. If it cannot be found in M but in universal. Now let's check universal. What cannot be found in M but in universal? We can find E in M. We cannot find F in M. That means M prime. You cannot find G in M. You cannot find G, G. H, you can find H in M. P, you cannot find P in M. No. Q, can we find Q in M? Yes. R, can we find R in M? No. S, can we find S in M? Yes. So this is M prime. That means it cannot be found in M, but in universal. Now let's go to the, as you can see, they say M prime union N prime. Let's do the N prime. So that means it cannot be found in N, but it is found in universal. So N, we have H. So we have H universal. We cannot take H. P. Okay, let me start from E. You cannot find E here. Write it. F, you cannot find F in N. G, you cannot find G here. H, you cannot find, yes, you can find H in N, so don't take it. P, you can find P in N, don't take it. Q, no. R, you can find it. S, you cannot. So, what we cannot find in this letter, we can find it in universal is many of prime or complement, anyhow they call it. Now let's now solve what they say. They say M prime union N prime equals to, what's not the answer? What is the meaning of union? Union means all. Union means all. Now that means when they say find this one union, that means everything inside this, the two, write it down. But note repetition. But no repetition. What does that mean? That means you can write everything inside the two, but don't repeat any letter. Don't repeat any letter. Now let's write. We have E, F, G, Q, X, R, P. Which one again you are going to see? E, F, G, Q, R, S, P. I think that's all. So we don't repeat any letter. Some people ask me that can we just follow it and not in the order of alphabet? It doesn't matter. The way you write members in a set, it doesn't matter. You cannot follow it in the alphabetical order. It doesn't matter. But no repetition when it comes to union. That's the answer for the question 1. Well, let's take another 2. Now, if you look at this also, it said if the universal set U is a natural number and this, that means universal is this. A universal is 1 less than or equals to x less than or equals to 9. And our P is x such that 1 less than or equals to x less than or equals to 4. And our Q is 2, 4, 6, 8. Is able to find P union Q close bracket prime. Now we have to learn how to interpret this. We call it range. Call it range. Now let's learn how to interpret this. You are given 1 less than or equals to x less than or equals to 9. Now, let's start from here. 1 less than or equals to x. When I say 1 less than or equals to x, that means that x is greater than or equals to 1. That's me. 1 less than x. What does that mean? That means x is greater than 1. So if 1 less than or equals to x, because less than is less than or equals to x, it also means that s is greater than or equals to 1. What is that number that is greater than 1? Because this thing means s is greater than or equals to 1. S is greater than 1. So if I say s is greater than 1, what will now be s? That is 2. Because the first number that is greater than 1 is 2. So that's the meaning of this. 1 less than or equals to s. 1 less than or equals to x. That means 1 is less than or equals to. If 1 is less than x, that means s is greater than 1. And if s is greater than 1, the first number that is greater than 1 is 2. But don't be confused. They say or equals to 1. Anytime you see or equals to 1, if they just stop like they say s is greater than 1, if number s is greater than 1, that means s is 2. That means s is 2. But they now say or equals to 1, that means s is 1. Because of this or equals to that is there. That's why we know that s will be what? 1. Now, that is for this. That means 1 less than or equals to x. That means 1, s is 1. You now say less than, because this one means less than or equals to 9. That means we are starting from 1, less than or equals to 9, we are stopping at 9. So that is the meaning of this. That means universal. Universal is starting from 1, 2, 3, 4, 5, 6, 7, 8, 9. That is universal. Now let's come to P. Are you going to interpret P? He said 1 less than or equals to x less than or equals to 4. If 1 less than or equals to x, that means s is greater than or equals to 1. 1 less than or equals to x. 1 less than or equals to x. That means x is greater than or equals to 1. That means s is 1. So they say or equals to 1, s is 1. So you now take this one as it is. The one that follows, take it as it is. S less than or equals to 4. That means less than, if it is ordinary less than 4, so we'll stop at 3. But they say less than or equals to 4. That means 1, 2, 3, 4. 1, 2, 3, 4. 4. So that is that. So you have to be mindful of that. If they say ordinary less than now, 4, you stop at 3. But they say less than or equals to 4. That's why I stop at 4. Take this one as it is, don't change it. But this one, because 1 comes first and s must come first. You know the s comes first here. So that's why we don't change it. S must come first, but 1 comes first. That's why I have to interchange it. But they say 1 less than or equals to x. That's why I change it to. It means that s is greater than or equals to 1. Okay? Now, and we have q already. Q. Our q is 2, 4, 6, 8. Our q is 2, 4, 6, 8. But we have to find the p union q prime. So let's find the p union q first. P union q. I told you we are going to write everything inside P and Q without repetition. You must not repeat any element. You must not repeat any element. This is P and this is Q. So I have 1, 2, 3, 4, and I have 6. Put comma and I have 8. And it's P union Q. But they said P union Q into bracket prime. What does that mean? That means that what cannot be found inside P union Q, but that can be found in universal. I told you This same prime means that it cannot be found in this thing, but it will be found inside what? Universal. Now let's check. One cannot be found inside here. One can be found in universal. One can be found here. Can be found in universal. One cannot. One, you can see it here. Two, you can see it here. This is our universal. Three, you can see it here. Four, you can see it here. Five, you can see it in here. Six, you can see it here. Seven, you can see it here. 8, you can see it here. 9, you can see it here. So that is 5, 7 now. That is not prime. In case they ask you something like this, number of, if they put n in front, what is the meaning of this? The meaning of this is that the number of, they are asking for the number of the element. And how many number of the elements you have? 1, 2, 3. That means it's 3. In case they say find this, you now put n in front of it. The meaning is that the number of the elements of course that is 1, 1, 2, that is the meaning of something like this. Let's now these are other examples under the set operations. They say P and Q are subsets of the universal. What is the meaning of subsets? That means they are sub, they are removed. I told you that one, universal is a mother set that give birth to other sets. That's why they call it subset. That means they are being removed from universal. That's why they say P and Q are subsets of the universal set. U, don't that we use U to represent universal. Define as, these are universal. So let's just interpret it. U, x such that s, this means x such that x is an integer and 1 less than x less than 15. Now, how do you interpret that? They say 1 less than x less than 15. If one, I told you, because 1 should not be in front of x. That's why if I say 1 less than x, what does that mean? I have to rewrite it to 1 less than x. 1 less than x. That means x is greater than 1. 1 less than x. That means x is greater than 1. And if x is greater than 1, that means x is 2. I mean, this thing starts from 2. I told you don't need to change this one. Don't change this one because s is already in the front of 15. You don't need to change it. And they say s less than 15. That means I'll start from 2. If s less than 15, how would that be the number 14? So that means I'll start from 2 and I'll end 14. That means 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's our universal. They say P. The P is x such that x such is on such that means such that doesn't mean. Or they can do it like this at times. And do like this. It still mean the same thing. When you see that line. The x such that x such that x is odd. P is odd. That means they are telling us that we should pick the odd ones, odd numbers. That's not the universal. Because I told that others say that comes under the universal, they are the subset of it. They actually came from it. Now, what are odd numbers? Odd number 3, 5, 7, 9, 11, 13. So those are the odd numbers there. Now, the Q said prime. I told you our prime number starts from 2. Our prime number must have prime numbers are numbers that can only be divisible by 1 and itself. So every prime number must have 2 factors. So if you go and take 1 as a prime number, we say prime number are numbers that are divisible by 1 and itself. So and you take 1 as a prime number, 1 and itself. So that means you are referring to 1 factor. So 1 is not a prime number. Prime number start from 2. So that means 2, 3, 5. These are the first 3 prime numbers. 7. Nothing can go in 7. Something can go in 9. Nothing can go in 11. It's a prime number. 13 is a prime number. So we have interpreted it. So what do they now ask us to find? They ask us to find number of P prime intersection Q prime. So that means let's do here. They said P prime. That means it cannot be found in P. Let's do P prime first, so that to be easier. P prime, it cannot be found in P, but it can be found in universal. What's our universal? This is our universal. Let's check it. Can 2 be found in P? No. Can 3 be found? Yes. Can 4 be found in P? No. Can 5 be found in P? Yes. Can 6 be found? No. Can 7 be found? Yes. Can 8 be found? No. Can 9 be found? Yes. Can 10 be found? No. Can 11 be found? Yes. Can 12 be found? No. Can 13 be found? Yes. Can 14 be found? No. That means it cannot be found in this P. It can be found in universal. That is the meaning of P prime. Now let's do Q prime. Cannot be found in P, but can be found in universal. 2 can it be found in Q? Yes. Can 3 be found in Q? Yes. Can 4 be found? No. Can 5 be found? Yes. Can 6 be found? No. Can 7 be found? Yes. Can 8 be found? No. Can 9 be found? No. Can 10 be found? No. Can 11 be found? Yes. Can 12 be found? No. Can 13 be found? Yes. Can 14 be found? No. Now, you're not saying you should find number of P prime intersection Q prime. It can be easy like that. So the meaning of intersection, when you hear the word, let it be big. The word intersection. Intersection means common elements between the two or more sets. So intersection means, and it is denoted with this N letter. So you get, so intersection means the common elements between the two or more sets. Now, we are going to take the one that is common to them. So that means, is 2 common? No. Is 4 common? Yes. Is 6 common? Yes. Is 8 common? Yes. Is 9 common? No. Is 10 common? Yes. Is 12 common? Yes. Is 14 common? Yes. But they said, you should find, they put this in front. That means the number of P prime intersection Q prime. So that means you count the elements. 1, 2, 3, 4, 5, 6. That is the meaning of this, the number of the elements that comes.